Okay. Hi, everybody. Today we are doing 4.4 proportional relationships. We're looking at tables. So at this time, you're going to do your exploration. Go ahead and pause me while you do that and give it about 3 minutes to let everyone finish. All right, let's look at the exploration. A coffee shop displays their prices on a chalkboard. The prices are proportional, but some of the information got erased. What is the constant of proportionality? So here, this would be our x, this is our y. So we have y over x is our k. To start, we are going to do 5.5 divided by 2. When I do 5.5 divided by 2, I get $2.75. So K is $2.75. That means for 1 cup of coffee, they're paying $2.75. If I'm looking at 3, if I get 3 cups of coffee, I would do 3 times 2.75. That would be 8.25. All right? How can you use K to find the missing prices on the menu? Well, we found our constant of proportionality. This is like our unit rate. And then we used what we know to find what we don't. How does the total cost change as the cups of coffee increases by 1? So every time cups increase by 1, the cost increases by $2.75. Pause if needed. Let's talk about our rate of change. The rate of change describes how one quantity changes in relation to another quantity in a proportional relationship. So that's what we've been doing this whole unit so far, proportional relationships. In a proportional relationship, the rate of change is equal to the constant of proportionality. Remember we talked yesterday about how every time, right, like I bought 1 more pound of chicken, I'm increasing my bill by that same amount every single time. The constant of proportionality or rate of change can be represented by K equals Y over X, and Y is our dependent variable. And X is our independent variable. The equation can also be written as Y equals Kx, which is K times X, to describe that proportional relationship. And the reason we can actually find that is it's just an equation. If I have K equals Y over X and I want to get X out of my denominator, I would multiply each side by X. Then these will cancel, leaving me with Y equals K times X. That's how I found that equation. Looking ahead, a proportional relationship is described below. We're using the information to find the rate of change, and then we are creating a table to represent the relationship. So here I have Y equals 9.5x. So what we're going to do is we can plug in our x's into the equation to find our y's. By doing so, if I have 0, I would do 9.5 times 0. Well, anything times 0 is 0. So there, my first y is 0. Moving ahead, I would have 9.5 times 1. Anything times 1 is itself. I get 9.5 for my y. For 2, I'm going to do the same thing. 9.5 times 2. That gives me 19. So if my x is 2, my y is 19. And finally, I will have 9.5 times 3. 9.5 times 3 is 28.5. So all I am putting in my calculator is I am plugging in my x to find my y. Therefore, k is just 9.5. Because remember, this equation right here is y equals kx. So my k actually was already given to us. The constant was already given. Okay, pause if needed. Let's look at question 2. As the x values increase by 2, the y values increase by 60. So, if I am looking here, okay, perfect. Let's see. So I said as the x values increase by 2, the y values increase by 60. So let's go ahead and actually figure that out because right here, I see my x values, they're increasing by 1. So when I see that in my y values, if this side is increasing by 1, I know if it's increasing by 2, I am going to then on this side increase by 60. So I am going to take 60 over 2, and I get that each time I increase by 30. So for 1x, I have 30. If I'm increasing by 1, I increase by 30. So 30 and 30 make 60. 60 and 30 make 90. 90 and 30 make 120. Looking here, my constant of proportion is 30. This one actually was tricky to me because I was thinking, okay, x increases by 2 and y increases by 60, but really all we're doing is we're finding the unit rate or the constant, and then we're using that to fill in our table. Go ahead and flip your page, pause if you need me to, or if you need to, and then we will keep going. All right, so Mrs. Hanhart asked her students to represent y equals 5x in a table. Remember, my equation is y equals kx. So that means that 5 is my k, my constant. So let's see which person did it, and then how do we know? So let's first do y over x. 5 divided by 0 is, can't divide by 0. It's an error. Okay, 10 divided by 1 is 10. 15 divided by 2 is 7.5. Hold on. Do I see anything that is constant here? No, nothing is constant. So Sasha, I don't think Sasha did it right. Let's look at Ronald. If I'm looking here, okay, y over x, 0 divided by 0 is 0. 5 divided by 1 is 5. Ooh, it's looking promising. 10 divided by 2 is also 5. 15 divided by 3 is 5. And 20 divided by 4 is 5. So go ahead and write this down. Every time I'm doing y over x, every single time I'm dividing, I get 5. That means my constant or my K is 5, and that is what I wanted. I see, let's do it in green because it's correct. I see my constant is 5. Some of you might be thinking, well, I see a 0. That's not the same thing as 5. But it's like saying, I'm buying nothing, so I pay $0, right? That makes sense. Nothing and nothing, that makes sense. If I buy one thing, it's $5. If I buy two things, it's $10. So that 0 does work. Let's go ahead and look at the last one that we will do together. So I have Camping Craze hires a graphic designer to create a new logo and marketing materials. The graphic designer charges Camping Craze $45 per hour. Let's underline that. It sounds important, especially because it says per hour. That makes me think of my K, my constant. So we're completing the table and then finding the rate of change. If I'm talking about per hour, I know that if my graphic designer works 1 hour, he is getting paid $45. So therefore, my K is 45. Let's go through 2, 3, 4, 5 hours worth of work. Go ahead and pause me. I want everyone to try to do this themselves on their calculator. Okay, so now I'm doing 2 times 45. Oops. If I am putting in 2 hours of work, I'm getting paid $90. 3 hours of work is $135. 4 hours of work is $180. And 5 hours of work is $225. When I'm looking at the rate of change and what it represents in this situation, I know that it's $45 per hour of work. Looking at my equation or finding an equation, all I want to show in this equation is that no matter how many hours or X he puts in, we can find how much they're going to get paid. So remember, my equation is y equals kx. K is my constant. K is my constant, so therefore I'm going to replace K with 45. Y is 45x. Go ahead, depending on the time, Mr. Sander, you can either decide whether you want to do independent practice or just jump on Math Space. But go ahead and flip to the next slide. I love you all, and I'll see you tomorrow. Mwah!